Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the rearrangement reaction. We are just started as a chapter number 3 and there are introduction regarding that rearrangement reaction as well as how many key rearrangement reactions are present there that we have seen. Number 1 is a 1,2 rearrangement reaction, number 2 is a pericyclic reaction, number 3 is a olefin metasynthesis reaction. So what are their meaning, how they are, what type of the things are mainly involved in that rearrangement reaction that we have seen so far. And today what we are going to discuss somewhat this mechanism of some rearrangement reaction involving carbocation. Do you know that carbocation means the carbon atom carries as a positive charge is known as a carbocation. After the removal of any halide group, any atom from that nearest to that carbon atom, and when they leave, when the bond are broken heterolytically, both the electron are going along with the leaving group and then the leaving behind the positive charge over there, and that type of the species are called as a carbocation. And as we know that there are the number of factors which can stabilize the carbocation. Yesterday we have seen tertiary carbocation is the most stable one because that positive charge gets stabilized due to the inductive effect. Electron donating inductive effect is present, that get stabilized, that positive charge get dispersal and therefore it increases. So yesterday we have seen how the stability order of that carbocation we have seen, and there are the factors such as inductive effect, resonance effect, hyperconjugative effect, steric effect, tautomerism, then hydrogen bonding. These are the so many factors which stabilize the carbocation, and that stabilization of that carbocation we have seen. And now today we are going to learn how this there are three key reactions are there. Number 1 is a 1,2 rearrangement reaction, number 2 is a pericyclic reaction, and number 3 is a olefin metathesis reaction. So these are the reaction, and now we are discussing mechanism of some rearrangement reaction involving carbocation. Now let's start with the example. What are the example we are going to see here? Let us see here when benzene is treated with N-propyl chloride in presence of anhydrous AlCl3. Anhydrous means there is no water molecule, and that's why no moisture are involved there, and that type of the species is called as a anhydrous AlCl3 gives isopropyl benzene as a major product. So that is the case we are getting. Let us see, we are talking about the examples, right? Now first example we have seen. Now here suppose if you remember here, this is a benzene, and that benzene should be treated with this one, and now in presence of anhydrous AlCl3, there generally gives the product. If you remember, this is the simplest Friedel-Crafts alkylation reaction, right? Friedel-Crafts alkylation reaction means what? When suppose let us see, let me give you here the benzene that will be treated with suppose CH-3Cl in presence of AlCl3. What it gives? This is a Friedel-Crafts alkylation reaction, right? This is the Friedel-Crafts alkylation reaction. What is happening here? This AlCl3 is reacted with this CH3 and we are generally obtain this type of the toluene, right? And suppose instead of methyl chloride, if you take this ethyl chloride CH3 CH2Cl, still you will get the compound this one CH2 and the CH3 ethyl benzene. But here see this you know that CH3 CH2 and CH2Cl, this is called as a N-propyl chloride. This is the name of this compound and this is a benzene, right? The expected product, if you use over here, suppose as this one CH3 CH2 and Cl, this is called as a N-propyl chloride, right? This and these are the same, only I am written over here according to as a zigzag pattern, that's it. And when expected product should be like this, C double bond O, CH2 and CH3, but we are not getting this is a major, this we are getting in the traces amount. Why this so? That's why we are talking. So this mechanism of rearrangement reaction involving carbocation, and that's why this is one of the best example. Here we are getting this type of the compound here like this, and another one you may get over here this one, this CH2, then you can write this one CH2 this is called as isopropyl benzene. This is we got isopropyl benzene. This is isopropyl benzene and this will be the N-propyl benzene. What do you think? Which one is a major and which one is a minor one? Look at this one. This is a expected product, as we know that this is a expected product, and this one is unexpected product. We are getting it is in the major form. This is the major and this will be the minor one. Why this so? Why this one is getting as a major and why this one is getting as a minor one? And now for maybe as a more than 90%, that is only as a 10% or 5% you can call it as a, why this so? If you remember the mechanism of this Friedel-Crafts alkylation reaction step by step, and mechanism we know that a detailed study of sequence of steps which are involved in the conversion of reactant into product is known as a mechanism. And what is the first step involved in the Friedel-Crafts alkylation reaction? We already learned this kind of the reaction in a semester number 3. Let us see here what is happening. Here the anhydrous AlCl3 is playing the important role in the Friedel-Crafts alkylation reaction. What does it do over here? It is a function, it is a Lewis acid. Remember, it is a Lewis acid. And what the Lewis acid, if you are not using as a Lewis acid, is there reaction possible? There is a no reaction at all, because under the in presence of Lewis acid, then and then reaction is going to occur, otherwise there will be a no reaction. What the Lewis acid do here? It generate the electrophile, and this is the function of Lewis acid. Remember always, in many competitive exam, this type of the question is appear. What is the role of Lewis acid in a Friedel-Crafts acylation reaction? There are multiple choice questions are there, and they have given as a 4 options are there. Remember, those are knowing the Friedel-Crafts alkylation reaction, the role of Lewis acid to generate the electrophile. So that is the main role of that Lewis acid to generate the electrophile. So that remember, and what it do, let us see here what is happening for first. In this case, the N-propyl, the AlCl3, anhydrous AlCl3 first react with the this one. So let us, in the case of, if you remember as a Friedel-Crafts alkylation reaction, step number 4, what is happening there? CH-3 Cl plus AlCl3, the reaction takes place, and we are going to get here CH3 positive charge plus AlCl4 minus. This is a Lewis base, and this is a electrophile generated over there. And in the second step, what is happening in the second step? In the second step, happening here, attack of the electrophile CH3 plus. Now we know that benzene is a nucleophilic in nature, and here is a electrophile, and this is going to attack over there, and you are going to get the product like this. Here remember, here is a CH3H and positive charge, that is the rhenium ion is formed over there. And after that, in the third step, what is happening? Third step, there is a aromatization, means this one CH3 and this H now is a positive charge, AlCl4 minus will pick up the proton from here, aromatization is back, and so that you are going to get the formation of the toluene over there. So this is a general mechanism of the Friedel-Crafts. This is known as a Friedel-Crafts alkylation reaction. Friedel-Crafts alkylation reaction, right? Now let us see over here what is going to happen. Why we are getting as a this unexpected product is a major, because whenever there is a reaction is taking place over there, so here as we know that this Cl plus AlCl3, in the first step, what is happening there? There is a formation of electrophile here, positive charge I am writing, and now plus AlCl4, which is a Lewis base of 10 over there, right? Conjugate base, that one. And now in the second step, as we know that this is a electrophile now here positive charge I am taking as a this. What is this? This is a primary carbocation, as we know that it is a primary carbocation, and primary carbocation is a less stable. What is? It is a less stable. Now there is a hydrogen 1,2 hydride shift over here. Hydride shift. Hydride means what? Remember, hydride and the H minus is called as a hydride and H plus is called as a proton. Now is a shifting from here to here. What do you get? You are going to get, here is a positive charge, here CH3, and now this is a secondary carbocation, and secondary carbocation is a more stable. Secondary carbocation is more stable, as we know that the stability order of the carbocation, that is the tertiary carbocation, is more stable than secondary than the primary. This is the stability order, and therefore now you got it, right? When this is there, when attacking this one, and that's why, and as we know that secondary carbocation is formed faster, and therefore it is attacking on the benzene ring, benzene nucleus faster as compared to as a primary, and therefore the major product obtained as a this one isopropyl benzene is a major product, and whereas N-propyl benzene will be the minor product. So this is the reason why this one we are getting as a major and this one is a minor one. Is that the reason, right? And now let us move on to the next point. What is the next point we are going to discuss? Second, this is a example number first, right? Example, you got this clear cut idea why we are getting as a isopropyl is a isopropyl as a major and why N-propyl is a minor. The reason, because first one, the AlCl3 is generate the electrophile, carbocation is formed over there. That carbocation, primary carbocation is a less stable, and then there is a 1,2 hydrogen atom. Hydride atom is shifted over there, and we are getting as a more the driving force behind it, the stability of that secondary carbocation is more than the primary, and that's why this is happening, and we are getting as this product. Now let's see the second example. Let me clean the board first, and then we will see the second example over here. Now let us see another one, second example over here. So second example will be this one. This is a, I think, OH, and that will be treated with what is that? Treated with HBr, hydrogen bromide. What kind of the product? It also gives the two products, and these two products are this one, bromo, and second one will be this one, Br. Now there are two products are possible when it is treated with this. What do you think? If you observe this reaction carefully, which product you should get here major and which one is a minor? Obviously, first product, this one is a major and this one will be the minor. Why this one? When you know the mechanism behind it, then and then you come to know that why this one is a major one and that why that one is a minor one, because we are talking about the mechanism of some rearrangement reaction involving carbocation. So this mechanism also involving as a carbocation, and as we know that mechanism is a language of organic chemistry. And then now look at, can you tell me the IUPAC name of this compound? Here 1, 2, 3 and 4, right? So at 2 position, so we can call it as 2 bromo, 2 bromo, 2 bromo. At 2 and 3 position, 1, 2, 3 and 4. At 2 and 3 position, 2, 3 dimethyl butane. So that is the IUPAC name of this compound. Can you tell me the IUPAC name of this compound? Yes. What is that? 1, 2, 3 and 4. Look at that. 1 bromo, 1 you mention or not mention, it doesn't matter. So but here 1 bromo and then 2, 3 dimethyl butane. So they are what? Can you tell me the relationship between these two? They are the isomers of each other. What kind of the isomer they are? Positional isomers. Only just by changing the position of the halide group we are getting as a different structure. So they are the positional type of the isomers. So we are not going to go in a stereochemistry, but here let us see how we are getting. Let us look at the mechanism over here. Now here this one, remember OH. Now HBr, right? HBr is, we know that they are the acid, right? There H and Br. Now this OH is going to attack on that hydrogen atom. Br is a departure, so that we are going to get over here this one. Now OH2 positive charge. Now remember OH is a bad leaving group. When this become as a good leaving group, now what is going to happen? Side product here leaving group is a Br minor, don't think about. Now what is going to happen over there? First one is a departure of, means there is a elimination of water molecule. Minus H2 get eliminated, and what you are going to get over here? Here you are going to get positive charge. What is the nature of carbocation over here? If you see this one, this will be the primary carbocation. This is the primary carbocation. As we know that it is a less stable one. And what is going to happen from here there is a hydride shift. 1 to hydride shift. This hydrogen shifted from here to here, and what you are going to get? You are going to get over here this one. One is a positive charge over there, and this is a what type of the carbocation it is? It is a tertiary carbocation, right? Tertiary carbocation. Tertiary carbocation, and as we know that stability order, tertiary carbocation is more stable than the primary carbocation, and therefore whatever this leaving group over there, it is getting, this one is a major product and this one is a minor product. Got it? This primary alcohol. Now Br is going to attack at this position, so we are getting as a minor product. When Br is attacking at this position, specifically it will be the major product. Got it? So this is a one more example of this compound, why we are getting this one is a major and this one is a minor one. Now let us see another one more example over here. Let's see. Now I am giving one more example, that is a third example. Let me clean the board here so that you can see properly. Okay, now let's see the example number 3 over here, right? This is example number 3. Now which one? Example number 3 will be this one. I think OH, that will be treated with simple hydrochloric acid. Now as we know that alcohol if alcohol OH is a bad leaving group, but when it is treated with acid, that get protonated and that converted into as a water, that becomes as a good leaving group, and good leaving group departs very easily without any problem. Now two products are like this. Two products are one Cl over here, then this one, another one. This is a Cl. This is a two product. These are the two products we got, and if two products are there, there is always competition between two. One is a forming faster, one is a forming as a lesser one, means which those are forming faster, they are the major product, and those are forming in a slower rate, they are the less or the minor product. Now among, if you observe these two structure carefully, now tell me which one will be the major one and which one will be the minor. Absolutely correct. First one is a major one and second one will be the minor one, right? This will be the minor one. So now can you tell me the IUPAC name of this compound? The IUPAC name of this compound, you can number from this or this, doesn't matter. 1, 2, 3 and 4. So at 2 position there is a chloro, so 2 chloro, 2 chloro, 2 methyl, butane. That is the IUPAC name of this compound. And what will be the IUPAC name of that minor compound? So here is a chlorine, so you start from here 1, 2, 3 and 4. So at 3 position there is a 2 chloro, 3 methyl butane, right? 3 methyl butane. That is the IUPAC name of this compound. Now the next point, how do we get this one and how do we get this one? That's the question. Let's see. When we see the mechanism gives you the clear-cut idea why we are getting that one, right? Now let us look at as a mechanism over here. Now as usual, here this is a OH will pick up the proton from HCl like this, and you are going to get over here this one OH, 2 positive charge. Don't think about that. And when this becomes as a good leaving group minus, H2O get eliminated over here like this, and so that you are going to get here the positive charge. What type of the carbocation it is? It is a, what type of the carbocation? It is a secondary carbocation, right? Carbocation, secondary carbocation. And now here is a one of the hydrogen atom, and this hydrogen atom get shifted over here. Now I am writing this like this. So 1 2 hydride shift taking place over there. This hydrogen goes from here to here. What do you get? Here you are going to get this type. Here is a positive charge. Look at this positive charge. What type of the carbocation it is now? It is a carbocation. It is a tertiary carbocation. This one, tertiary carbocation. And then if you add, here is a HCl, Cl minus, what is going to happen? It is going to attack over there, and you are going to get this product as a major one. Got it? So in this way we can show the mechanism, or all these reaction whatever we are discussing, all are involving as a carbocation, and therefore the more carbocation is more the tertiary carbocation are more stable than the secondary, than the primary, and therefore the what we can call it, if the substrate permits, they rearrange, because that atom has a special tendency to rearrange in a special arrangement of that atom around that carbon, and we are getting as a that type of the carbocations are there. So this is a example we have seen over there. 3 examples so far we have learned. Now let us see one more example how we can show that. 4th example now, I think now is a next one is a 4th example. From that we can see the clear idea about this. I think 4th example, before starting that 4th example, 4th, 5, 6, there are number of examples are there. I think our time is exceed over here. So let us stop today here. Remaining examples, remaining points we will see in the next time. Let us stop today here. Have a nice day. Thank you.